Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, time to continue further with Mathematics class 11th, and today we'll be dealing with miscellaneous exercise of Binomial Theorem. Yes, the very important miscellaneous exercise will have questions from all the topics covered in the chapter. Not only that, some more questions which develop your thinking further. Some difficult questions will also be included over here which are not covered in the previous exercises, right? So let's begin with each of these questions over here. Let's begin with the first one. Remember, you are also supposed to attempt all the examples from this exercise related to this exercise as well, so that you get a better idea of the questions over here, and you can solve the questions in the examination, any kind of examination that you have upcoming in front of you, right? So continue further with the first question that we have. What does the question say? Which says that find a, b and n in the expansion of a plus b whole power n if the first three terms of the expansion are this, this and this respectively. So we're supposed to find a, b and n. There are three unknowns and there are three conditions, right? Let's use those conditions to solve this question. A, b and n in the expansion of this. First three terms on the expansion, right? So a plus b whole power n, what do you think will be the first term? The first term will be nc0 a power n, okay, b power 0, plus nc1 a power n minus 1 b. This is what you have. The next term will be nc2 a power n minus 2 times b square plus dot dot dot. This is what you have, right? And since it is given that the first three terms are known, let's write nc0 a power n will be equal to 7 to 9. And this gives me nc0 is 1. This will tell me that a power n is equal to 7 to 9. That's the first condition. Can we find the value of either a or n from here? I think it will be difficult. This can be written as 9 power 3, or this can be written as 3 power 6. This can be written as root 3 power 12 as well, or something else maybe, right? So we are supposed to have another equation related to a and n maybe. Then the second term says nc1 a power n minus 1 b is equal to 7290. nc1 is what we have. nc1. Let's focus on this. nc1 a power n minus 1 b is equal to 7290. Okay, not 2790. This is 7290. Okay, let's simplify this. This is n is okay. This is n times a power n minus 1. Okay, times n times b is equal to 7290, which is the second equation that you have. Okay, this is the second equation. N times a power n minus 1 times b is 7290. The next equation is nc2 a power n minus 2 b square is given to be 30375. What does this imply? This implies that nc2 is n minus 1 by 2 times 1 times a power n minus 2 times b square is equal to what? This times b square will be equal to 30375. This is the third equation. Right? These are the three equations. And how do we go about solving these equations? Okay, let's see the approach of solving these equations one by one. So in this you have n, a and b. In this you have n, a and b. In this you only have a for that matter. One of the approaches which comes to the mind is that if possible, can you eliminate b from these and maybe get another equation in terms of a and n? You may, but do you also realize that this a power n is pretty complicated? Yes. So instead of going in that direction, maybe we can go in another direction. And think in other terms. Let's divide these two. And see what we get over here. Okay. On dividing 3 by 2. Let's divide 3 upon 2. What does that give us? This gives me, let's try to simplify in this manner, n times n minus 1 by 2 times, this is a power n upon a power 2, and then you have a b power 2 already over here. This is the left hand side. What about the denominator? Denominator of 2 will be a power n over a. Then you have a n and you have a b also over here. This is equal to what? This is equal to 30375 over 7290. This is what I get, right? This is what I have. Is that okay? Yes. And when I simplify this, what do I get? A power n will get cancelled. B and A will also get cancelled. What remains is this n goes, this A power n also goes, this B square goes, this A square goes, A remains, B n minus 1 by 2A. This remains, right? Which is equal to that expression over here. What is this expression? This is 30375 upon 7290. Will it get cancelled? 7290 and this. It may get cancelled, but what do we have over here? Let's see. 30375 and 7290. You have a multiple. You have a factor of 5. You also have a factor of 3 as well, right? So we can cancel a factor of 15 directly. Let's cancel a factor of 15 over here in the numerator and denominator. 15 times 2 is 30. Then 0, then 2 and 5. This is what I get over here. This 2, 0, 2 and 75 will be 5 times, right? And 15 times what you get over here is 4 is 60, 129, 8 times is 120 and 90 will be 6 times. 486 is what I'm getting over here. And this again goes with 3, yes. This again goes with 9 for that matter, right? So let's cancel a factor of 9 once again. This will become 9 times 2 is 18 and 9 times 2 is 18 and 9 times 5 is this, and this goes 9 times 5 is 45 and 36, 54 is what you get. Okay, and you may observe that again you can cancel a factor of 9, yes. So 9 times 6 is this and 9 times what? 9 times, can you observe that? This is 9 to 25. 25 by 6 is what I'm getting over here. This is 25 by 6. Okay? Is that okay? Yes. This is 25 by 6. And what else? What else? So what I observe from this is that this 2 can go over here. That will become 50 upon 6. And that will be simplified to, let us say, 50, or we can say that this will be 25 upon 3. Right? You can cancel this 2 and this will be 3 over here. This becomes Bn upon A minus B upon A is equal to 25 over 3 is what I'm getting. You may observe this is what I'm getting. Okay. This was 3 divided by 2. Okay. You can also divide 2 and 1, and what does that give us? 2 divided by 1. Now this will be simpler probably. That's what I can see over here. This is A power n minus 1 times n times B over A power n, simply A power n. This is equal to 7290 over 729. Okay. And if you may observe, this is simply A in the denominator. This gives me NB upon A is equal to 10. This gives me NB upon A equal to 10 means this and this. This gives me NB upon A is equal to 10. This is equation number, let's call this equation number 1, 2, 3. Let's call this 4 and let's call this equation number 5. Okay. We have equations 4 and 5 now. Using 4 and 5, from 4 and 5, we see that NB by A is 10. Let's use that 10 over here. Let's use that 10 over here. 10 minus B by A is equal to 25 by 3, and this gives me B upon A is equal to 10 minus this 25 by 3, right? This will be 30 minus 25, which is 5 by 3. This becomes 5 by 3. Okay. B by A becomes 5 by 3. This is another equation once again. This is not the value of B or A. This is another equation. Let's call the 6th equation. Okay. So many equations are obtained. When will we get the values of N, A and B? We are almost there. How? You observe this is B upon A. This is also B upon A. And using 5 and 6. Using 5 and 6 will give us N will be equal to N times B by A is 5 by 3 is equal to 10, which gives me N equals 30 by 5, which is 6. This is what you get. You get the value of N from here. Once you get the value of N, therefore, use the original equation. Original equation, yes, this is the original equation. We were not aware of the values of either A or N, but now we are aware of the value of N. So once we are aware of the value of N, we can use this to get the value of A very easily. So let's get the value of A after this. From there, I am continuing over here. Therefore, in equation 1, we get a power 6 is equal to 729, and 729 is 3 power 6. 729 is same as 3 power 6. This gives me a equals 3. We obtained n equal to 6. On the basis of this, a is equal to 3. And do you observe equation number 6? Yes. Can you get the value of a from there? Sorry, can you get the value of b from there? Therefore, equation 6 implies b will be equal to b upon a. B upon 3 will be 5 upon 3, which implies b equals 5. And yes, that's the answer for this question. The value of n, as you may observe, is 6. The value of a is 3. The value of b is 5. And that is what we were supposed to find. So calculations, yes, there are a lot of calculations. Equations 1, 2 and 3 were supposed to be formed. First of all, these are given. On the basis of this, we get simplified equations, right? We get simplified equations and then we get the values of a, b and n. Could we have moved in any other direction? Yes, there's another possibility. We could have moved and maybe we could have used this a power n over here, although we would have obtained similar equations for that matter. Similar equations? Yes, similar equations, not very different equations over here. But that's all for this question, as you may see over here. Answers, once again, n equals 6, a equals 3, b equals 5. That's all for this question. The next question says, find a if the coefficients of x square and x power 3 in the expansion of this are equal. In the expansion of this, okay, coefficients of x power 2 and x power 3 is what we are interested in. So let's write the expansion first. Let's write the general term of the expansion first. General term is tr plus 1, which will be equal to 9cr 3 power 9 minus r ax power r. Okay, this is 9cr, which is okay. 3 power 9 minus r is also okay. This is a power r times x power r. Okay, now what are we interested in? We are interested in coefficient of x power 2 and coefficient of x power 3. So for x power 2, we have r equals 2. X power r, x power 2, when we compare, we get r equals 2, implies coefficient of x power 2 will be equal to what? This will be 9c2, 3 power 9 minus 2, a power 2. Okay, this is what you get. This is, when simplified, this is 9c2, this is 3 power 7, this is a square. Let's call this equation number 1. This is coefficient of x square. Now what about x power 3? For x power 3, we get r will be equal to 3. Okay. Therefore, coefficient of x power 3 will be equal to what? This will be equal to 9c3, 3 power 9 minus 3, a power 3, that's it. 3 power 9 minus 3, a power 3. What is it equal to? This is 9c3, this is 3 power 6, a power 3. This is equation number 2. And you are given that coefficient of x power 2 and coefficient of x power 3 are equal. Since you are given that the coefficients of x power 2 and x power 3 are equal, therefore, from 1 and 2 tells me that this and this are equal. 9c2 times 3 power 7 times a square is equal to 9c3 times 3 power 6 times a power 3. And this further tells me that, let's cancel those a squares. Yes, let's cancel those a squares and let's simplify. Yes. So this over this will be actually, this a square goes there, and what you get on the RHS is a. What you get on the LHS is 9c2 times 3 power 7. This will remain in the LHS, and that 9c3 upon 3 power 6 will come in the denominator. Let's simplify this further. What's 9c2 equal to? 9c2 is 9 times 8 upon 2 times 1. Okay, 3 power 7 upon 3 power 6 will be simply 3 in the numerator. What about 9c3? 9c3 will be equal to 9, 8, 7, 3, 2, 1. That's what you'll have. 9c3 will be this. Okay, I observe that 9 times 8, 9 times 8 will get cancelled. This 2 will get cancelled with this 2. And a will come out to be, in the numerator you have 3 times 3, which is 9. In the denominator you have 7. So this is 9 over 7 is what I will get over here. This is 9 over 7, that's what I'll get over here. Can we also verify this answer? Yes. Let's check. 9c2 3 power 7 a square will be 81 upon 63, yes, sorry, 49. And similarly, we can check that value. This will be a power 3. This is 9 power 3 upon 7 power 3. And you'll have extra a 9 and this basically a 7 and a 3 extra over here. As compared to this, 7 and 3 will get cancelled. Yes, what will be required is this only. This is A equals, this gives me A equals 9 upon 7, and that is my answer for this question. Let's solve this question next. The question says find the coefficient of x power 5 in the product this. 1 plus 2x whole power 6, 1 minus x whole power 7 using binomial theorem. Now how are we supposed to find the product of this? We'll have to expand this, we'll have to expand this, and we'll have to write the coefficient of x power 5 after that. Let's do it. Let's do it. So let's expand 1 plus 2x power 6 first. 1 plus 2x power 6 times 1 minus x power 7 will be equal to what? This will be equal to, let's write this product, 1 plus 2x power 6, this is 6c0, 1 is gone, 2x power 0 is what you'll get, plus 6c1, 2x power 1, plus dot dot dot, the last term will be 6c6, 2x power 6 is what I'll get. What about the next term? In the next bracket, what you'll have is 1 minus x whole power 7, this will be 7c0, 1 power 7, which is okay, minus x power 0 is what I'll get. Okay, plus 7c1 minus x power 2 plus, sorry, minus x power 1 is what I'll get, not minus x power 2. This is minus x power 1. Then 7c2 minus x power 2 plus similarly dot 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 7c7 minus x power 7 is what I'll get over here. Yes. And now once we multiply these two expressions, we'll get a lot of terms. We'll have different powers of x over there. Which of these terms will have x power 5? We are only concerned with x power 5. Since we are only concerned with x power 5 over here, let's try to focus on finding coefficient of x power 5 only. So in this product, coefficient of x power 5. How will you get x power 5 over here? You see the power of x starts from 0 and goes up to 6. The power of x starts from 0 and goes up to 7. So for getting x power 5, this x power 0, this term having x power 0 should get multiplied with some term over here having x power 5. Yes, and that's the key. That's the key. That coefficient x power 5 will be the 6c0 2 power 0 gets multiplied with. Since you have 7c2 minus x power 2, you'll have 7c5 minus x power 5. That's what we are interested in. 7c5 minus x power 5 will be actually minus 1 power 5. This is what I'm interested in. This will be the coefficient of x power 5. Is this all? No. This is from product of this with this. X power 1 can also be multiplied with x power 4 over here. Let's do that. That will also give us x power 5 term. Yes. Like terms have to be added together. So let's add that term. 6c1 times 2 power 1 gets multiplied with 7c4 times minus 1 power 4 from here. Is that okay? Yes, that's okay. What next? You'll have another term. X power 2 from here and x power 3 from here will get multiplied. X power 2 from there will be 6c2. You get the idea. 6c0 2 power 0, 6c1 2 power 1, 62 2 power 2 gets multiplied with 7c5, 7c4, and here you will have 7c3, right? This is x power 2 term, this is x power 3 term. In the two brackets, they will get multiplied, give us x power 5, yes. This is minus 1 power 3 plus another term. You'll get 6c3 over here, this is x power 3. You'll have x power 2 over here, they will multiply together. The 6c3 times 2 power 3, 7c3 times minus 1 power, 7c2 times minus 1 power 2 is what you get, right? This is what you get. What else? 6c3. After 6c3, you'll have a 6c4 and a 6c5 as well. Yes. Let's multiply them. 6c4 times 2 power 4, 7c1 minus 1 power 1 plus 6c5 2 power 5 times 7c0. This term 7c0 minus 1 power 0. Those are the terms that you have. For finding coefficient of x power 5, you'll actually have 6 terms in the product which will have x power 5. Those will be like terms. We have added those terms. We have added the coefficients, right? This 6C0 is 1, 2 power 0 is also 1. 7C5 is important with a minus. So this is minus of 7C5. That's what we are interested in. First thing. 6C1. Let me write that 6C1 as it is. 6C1 into 2 into, this is 7C4 with a minus 1 power 4, which will be plus. This is 7C4 plus. What next? You have 6C2 times 2 square. 2 square is 4. 4 times 6C2. But then you have a minus remaining over there. 7 power 3 is okay. But then you have a minus remaining over here. So this will be a minus 4 times 6C2 times 7C3 is what we have. Next term will be a plus. Yes. So plus, what you get is 2 power 3 is 8. 8 times 6C3 times 7C2 is what I get. Yes. Next term over here is a minus. So this will be minus 2 power 4 is 16 times 6C4 times 7C1 is what I get. Yes, I'm writing that expression. And this will be plus 32. 2 power 5 is 32 times 6C5 times 7C0, which is 1. You're not supposed to worry about that. Equal to, now this is minus 7C5. Let's write that properly. This is minus 7C5 will be 7 times 6 upon 2 times 1. The same as 7C2, right? So this is 7 times 6 over 2 times 1, which is okay. Plus, what do you have over here is 6C1 times 2. This is 2 times 6, okay. 7C4 is same as 7C3. This will be 765 upon 3 to 1. Plus, what is this? Okay, this is a 4 and 6C2. So let's write this 4 separately. This is actually a minus. There's actually a minus over here. Let's not miss that minus. Okay, and we have 4 times 62. 62 is 65 upon 2, 1. What 7C3? 7C3 is same as this. This is 765 over 3, 2, 1 plus 8 times, what is this? 6C3. 6C3 is 654 upon 3 to 1. Into, we have 7C2, which is 7 times 6 upon 2 times 1. Minus 16 times 64. 64 is same as 62, which is 6 times 5 over 2 times 1. 7C1 is 7. Plus this is 32. 65 is simply 6. That's what we have, right? On multiplying these, what do we have? This is 7 times 6 is 42 by 2 is 21 with a minus. This is minus 21. Plus, what do you have over here? Okay. So this is 3 times 2, which is 6. This goes, and what remains is 7 times 6, 42 times 5 2s is 10. So this is actually 7 times 6 is 42 times 10 is 420. This is 420 over here. That remains. What next? What next? Let's take a look at the next expression over here. And what do I see is this 3 times 2 is 6. This goes away. And you have a 5, you have a 7, you have a 5, you have a 6 and 4. This 2 will go over here. Now let's take a look at this. This is 7 times 3, which is 21. 5 times 5 times 4 is 100. 100 times 21. Yes, that's what you have. 100 times 21 is actually equal to 100 times 21 is 2100. This is minus 2100, right? Then what next? This is minus 2100, and what after that is this term. Let's take a look at this term. 3 times 2 is 6 again, okay. You have a 2, okay, and you have a 4. Let's cancel them, and you have a 2 remaining. So 5 times 2 is pretty simple, that's a 10. 6 times 7 times 8, what is this? Now this is 8 times 6 is 48, 48 times 7. Can we find that easily? Yes, that's 48 times 7 would be 50 times 7 minus 14, which is 350 minus 14, 336 times 0, this is 3360, that's what you get. Then you have a minus over here, yes, and what do we have? You have, this is 3, 16 times 5 is 80, and 7 times 3 is 21 actually. So 80 times 21 is 8 times 21 is 1680. So this is 1680. Okay. This is the last term. 6 times 32 is simple. This is 60, 18 and 12, 192 over here. Okay, this is 192. Yeah. What else? What else? Let's write this sum. Let's add the positive terms and negative terms, or can we add them together as well? Maybe, but let's add the plus terms first, and let's add the minus terms along with that. In plus, we have 420, we have 3360, and we have 192. Let's add them together. 0, 20, 60, and 92. That's what we have. 80 and 92. 80 and 92 would imply at the end you have a 2 and 8, 16, 17. This is a 7, right? 8 plus 9 is 7. 17 basically, and you have a 1 carried forward. 1 plus 1 is 2. 2 plus 3 is 5. Plus 4 is 9. Okay, you have a 9 over here. And is there anything carried forward to the 1000 place? Nothing is carried forward to the 1000 place. This is 420, 360 and 192 will be 972. You have a 3000 remaining. This is 3972. This is what I get. In the minus, what do you have? You have 21, 2100 and 1680. So let's add them together. 2100 and 1600 is 3700. 3780. 3780. 3801. This will be 3801 with a minus. And what is that difference? 72 minus 1 is 71. 39 minus 38 is 1. This is 171, which is the required answer for this question. This is 171. The coefficient of x power 5 in the product of this is 171. Calculations, yes, there are a few calculations. Okay, there are quite a bit of calculations, but this is the final expression that you get over here. Right? Is that all? Yes, that's all for this question, as you can see behind me. Let's discuss this question next. The question says, if a and b are distinct integers, prove that a minus b is a factor of a power n minus b power n whenever n is a positive integer. Hint, there's some hint given over here. That is, write a power n is equal to a minus b plus b whole power n and expand using that. Okay, let's try to utilize this knowledge, this information that is given to us, and solve this question. So a and b are distinct positive integers. A minus b is a factor of a power n. First we'll write a power n as a minus b plus b whole power n. If you observe, let us consider this as one term and this is the second term. So this becomes the first term, this becomes the second term, and now you can apply binomial theorem on this. Yes, how do we do that? This is NC0 times a minus b, the first term power n, plus NC1, first term power n minus 1, second term power 1, b, plus NC2, a minus b, power n minus 2, b square. There's a b square as well there. Let's write that b square also. Plus dot dot dot. And what do we have? The last two terms. Let's write the second last term first. What is that? NCN minus 1. This will be a minus b power 1 and b power n minus 1. The last term will be NCN b power n. This is what you'll get. Right or not? Yes. Observe the summation and then think of, let us say this is NCN, which is 1 times b power n. We can bring this on the left hand side, and what do we get? We get a power n minus b power n. A power n minus b power n, which is equal to what? This is equal to, take a look at this carefully. Here you have a minus b. In this you will have a minus b whole square, the term before that, a minus b whole power 3, and over here you have a minus b power n. Can I take out a factor of a minus b from each of these remaining terms? Yes. If I remove this factor, this becomes NC0 a minus b power n minus 1. Okay. Plus NC1 times a minus b power n minus 1 will reduce to power n minus 2. Plus dot dot dot. And the last term will be NCN minus 1. Mind you, this term is already moved on the LHS. So this term times a minus b. By the way, there's a b over here and there's a b power, just a minute. There's a b power n minus 1 over here, and then the bracket closes, right? This is what you have. This is what you have. Let's take a look at these terms once again. NC0 times a minus b power n. There's a minus b outside. So what remains is a minus b power n minus 1. NC1 times a minus b power n minus 2 remains, since a minus b has been taken out. B is already there. Here also you'll have a minus b power n minus 3. Similarly, in this term, you'll have nc n minus 1 times b power n minus 1. And if a and b are integers, nc0, nc1, nc2 are all integers. So this overall, this expression over here will be an integer as well. This will be integer. Okay. So what you get from here is a power n minus b power n is equal to a minus b times some integer. And with the help of this knowledge, what can you say? You can comment that a power n minus b power n is divisible by a minus b, or a minus b is a factor of a power n minus b power n. That's what you can say, and yes, that is the proof of this question. You can write one line after this, that is, from here you can comment that a minus b is a factor of a power n minus b power n. That's true. That's the complete solution of this question over here. Let's discuss this question next. What does the question say? Evaluate root 3 plus root 2 whole power 6 minus root 3 minus root 2 whole power 6. What are we supposed to do in this one? We'll expand this and we'll expand this, then we'll subtract these two terms and see where does that take us. We have to find the value of this. Okay, let's do it. Okay, so let me write the expansion of root 3 plus root 2 whole power 6 first. This is equal to what? So there will be 7 terms in all. What are the terms? This will be 6c0 root 3 power 6, root 2 power 0, which is 1, that's not required, plus 6c1 root 3 power 5 square root of 2, plus 6c2 root 3 power 4 root 2 square, plus, let me write another term, 63 root 3 power 3 root 2 power 3 plus dot dot dot, and the last term, let's write the last term after this. What is that? This is 6c6 root 2 power 6. This is what you will get. Similarly, let me write the second expansion. What you'll have is root 3 minus root 2 power 6 is what you'll have. And if you observe, there is a minus over here, that's the only difference. So alternate terms will be plus or minus. This will be plus, this will be minus, this will be plus, this will be minus, and that's the only difference that will be there. Since square root of 2, instead of square root of 2, we have minus square root of 2. So 6c1 will be negative, 6c3 will be negative, 6c5 will be negative, right? So this is 6c0 root 3 power 6 minus 6c1 root 3 power 5 square root of 2 plus 6c2 root 3 power 4 square root of 2 whole square minus 6c3 square root of 3 power 3 square root of 2 power 3 plus dot dot dot. What will be last term is actually 6c6, so this will be a plus sign. The term before this will be a minus sign. Right? This is what you have. What next? We want to take the difference of these. Let's take the difference of these. Let us take the difference. And how do we do that? Let's see. Subtracting them, root 3 plus root 2 power 6 minus root 3 minus root 2 power 6 will be equal to what? Observe the subtraction very carefully. So these terms will get cancelled, yes. These terms will get added. This minus or minus this will become twice 6c1 square root of 3 power 5 square root of 2. Okay, let's take this in a bracket. Next term, this will get cancelled, whereas these will get added. There will be 6c3 root 3 power 3 square root of 2 power 3. Then you'll have another term. If you observe 6c1, 6c3, and the next term will be 6c5. Yeah. So you observe the series. This is 6c5 root 3 power 1 root 2 power 5. Then 6c7. No. There is no 6c7. There is only term up till 6c6. So this is what you have. And now we are only supposed to simplify this expression. Let's do that. These are odd powers. These are all odd powers, you may observe, right? So let's take out a root 3 common and let's take out a root 2 common. From this, all three terms. Okay, so you get a 2 times root 3 times root 2, and in the bracket what do I get? Let's observe 6c1. 6c1 is simply 6. You'll have root 3 power 4 over here and root 2 power 0, which is 1 only. Next, 6c3. What is 6c3? 6c3 is 6 times 5 times 4 upon 3 times 2 times 1. This will, 1 root 3 has already gone out. This will be root 3 square will remain over here. 1 root 2 has already gone out. This will remain as root 2 square plus 65 is 6. Root 3 has gone out. Root 2 power 1 has gone out. So what will remain is root 2 square power 4. This is what will remain, right? What next? This becomes 2 square root of 6. Root 3 times root 2 is square root of 6. In the bracket you have 6 times root 3 power 4, which is 3 power 2, that is 9, plus, what is this? This is 3 times 2, which is 6 gone. 5 times 4 is 20. 20 times root 3 square is 3 and root 2 square is 2. You observe that. Plus, next term is 6 times root 2 power 4, which is 2 square, that is 4. This is what you have. The final result that you will be getting is this. 9 times 6 is 54 plus 20 times 6 is 120 plus 6 times 4 is 24. This is what I am getting. 120 plus 20 plus 50. What do you get is 198 is what I am getting. Yes, 198 times 2 is 396. Square root of 6 is also there, and that is the final answer for this question, as you can see behind me. That's the complete solution of this question over here. Is that all? Yes, that's all in this question. Find the value of a square plus under root of a square plus 1, sorry, a square minus 1 whole power 4, and then next term is a square minus under root of a square minus 1 whole raised to power 4. Now how do we go about solving this one? This is a binomial term and power raised to power 4. This is a binomial raised to power 4. So we'll apply binomial theorem on each of these and then add them together. So the first thing that we have is a square plus square root of a square minus 1 whole power 4. Okay, you have a binomial expansion. Yes, there will be 5 terms in this. Since the power is 4, there will be 5 terms. Let's write the terms one by one. 4c0 a square power 4 is what I'll get. Square root of a square minus 1 power 0 will be 1. Okay, the next term will be 4c1 a square power 3 under root of a square minus 1 is what I'll get over here, power 1. Next term will be 4c2 a square power 2 under root of a square minus 1 power 2 is what you'll get over here. The next term will be 4c3 a square power 1 under root of a square minus 1 power 3, and the last term will be 4c4 under root of a square minus 1 power 4. This would be the last term over here. Take a look at this complete expression as written over here. Right. Let us write the next expression. That's the next expression. What's the next expression? A square minus under root of a square minus 1 whole power 4. If you write this expression, what will happen is alternate terms will become minus. This term will remain plus, but minus under root of a square minus 1 will make this term negative, this term negative. There will be 2 negative terms and 3 positive terms, right? So this will remain as it is. 4c0 a square power 4, as you may have clearly observed, minus 4c1 a square power 3 under root of a square minus 1 is what I'll get over here. The next term will be plus 4c2 a square power 2 under root of a square minus 1 power 2. The next term will be minus 4c3 a square times under root of a square minus 1 power 3, and the last term will be plus 4c4 times under root of a square minus 1 power 4. What next? Well, next we'll add these two terms. Let's add the terms together, and what you get is this is a square plus a square minus 1 in the under root power 4 plus a square minus under root of a square minus 1 power 4. This is what you get. And on adding them together in the RHS, you have these two terms will get added. 2 times 4c0 a square power 4. Okay. These two will get cancelled, right? The next term which will come is 4c2 and 4c2 will get added. This will become 2 times 4c2 a square and under root of a square minus 1 square. This is what you'll get. What about the next term? Next term, this will get subtracted and they will get cancelled. This will get added, so you'll get 2 times 4c4 under root of a square minus 1 power 4, and this is what I get. Right? Can we simplify this expression further? Yes, we can simplify this very well. Let's do that. This is 2, 2 is okay. And what next? In the bracket, what do you have? 4c0 is 1, a square power 4 is a power 8 plus 4c2. 4c2 is 4 times 3 upon 2 times 1, which is 6 times, this is a power 4, since a square square is a power 4. And what is this? This is under root of a square minus 1, which is simply a square minus 1. Okay, plus 4c4 is simply 1, and under root of a square minus 1 power 4 will be a square minus 1 whole square. So a square minus 1 whole square is what I'll get in this bracket. Let's try to simplify it further. This is 2, which is okay. This is a power 8 plus 6 times, let's multiply them together. What you get is 6a power 4 times a square is 6a power 6 minus 6a power 4. This is what you get. And what about this one? This is a square minus 1 whole square, which is a power 4 minus 2a square plus 1 in the bracket. This is what you'll get. Okay, so let's add the like terms together. This is a power 8, 2 times bracket, and then you have a power 8. Is there any other term of 6a power 6? No, this is 6a power 6. But 6a power 4 and a power 4. Minus 6 plus 1 is minus 5 a power 4. Minus 2a square is already there, plus 1, and yes, this is my answer for this question over here. Is that all? Yes, that's all for this question. As you can see behind me, let me get aside so that you can take a look at the complete solution over here. Let's solve this question. Find an approximation of 0.99 raised to power 5 using the first 3 terms of its expansion. We are supposed to find this using binomial expansion. How do we go about doing that? Okay, so 0.99 raised to power 5 using the first 3 terms. That's what we are interested in, first 3 terms. Okay, so what kind of an expansion are we looking at? Let's write 0.99 as 0.01, 1 minus 0.01 power 5, and this is the expansion that we are looking at. This is the expansion that we are looking at. Okay, so what is this expansion? This is 5c0, the first term is 5c0, 1 power 5, which is okay. Next, since there's minus, this will become 5c1, 1 power 4, 0.01 raised to power 1. There's already minus, has been taken care of. The next term will be 5c2 and 0.01 square. Okay, the next term will be 5c3 with a minus, but that's not required, right? There will be plenty other terms, but we are looking at approximate value. So this is approximately equal to, since we are looking at approximation, this is approximately equal to 5c0, which is 1, minus 5 times 0.01. This plus 5c2, which is 10 times 0.01 square. What is that? 0.0001. This is the approximate value. And what does this simplify into? This is further equal to what? This is further equal to 1 minus 0.05 plus 0.0010 is what I get, right? And let's simplify this. This is 1.001 and 0.050 will be subtracted. 1.0010 minus 0.0500 is what I'll get. So at the end you have 10 and 100 minus 5 will be 95. So 0.9510 is what I'm getting over here. That's the required answer. 0.9510 is the answer that I'm getting. 0.99 power 5 is approximately equal to this. And before you studied binomial theorem, this was very difficult to estimate, right? Right now, it's become very easy to estimate this expression over here. Is that all? Yes. That's all in this question. Let's solve this question. What does the question say? Find n if the ratio of the 5th term from the beginning to the 5th term from the end in the expansion of this is root 6 up to 1. Now that's interesting. 5th term from the beginning is very simple. What about the 5th term from end? So for x plus y power n, we know something. Rth term from end is equal to the n minus r plus 2th term from beginning. This is what we know, right? It is rightly given in a textbook, and while studying binomial theorem, you would have gone through this, that rth term from end is same as n minus r plus 2th term from beginning. How do we get that? Let's imagine if there are 10 people in a line, okay, and if you are, let us say, 10 people, and if you are, let us say, fourth from the beginning, if you are fourth from the beginning, then what's your position from the end? So if your position is kth from the end, then what happens is, let's count the numbers. There are 3 people before you and you are the fourth, so there will be 6 people behind you. You will be actually 7th from the end. If you are 4th from the beginning, you will be 7th from the end, and 4 plus 7 is actually not equal to 10, but it is equal to 10 plus 1. Do you realize that? Yes. So number of terms is important, and accordingly we will consider the position from the beginning and position from the end. Let's see what do we have over here. For x plus y power n, the number of terms is n plus 1. The number of terms is n plus 1. From the end, if your position is rth, then from the beginning your position is kth, where k is question mark. So k plus r is equal to n plus 1, and then you have a plus 1 extra, right? And this implies that k equals to n minus r plus 2. This is what you have, and that is what is given over here, right? This is a simple analysis of finding this, right? So rth from the end implies n minus r plus 2th term from the beginning. And once we are through with this, we can very easily solve this question. Let's try to solve this one. What do we have? Okay, we have a ratio of 5th term from the beginning to 5th term from the end in the expansion of this. So 5th term from end, what will that look like? 5th term from end will be n minus r, that's 5th term, plus 2th, that is actually n minus 3th term from beginning. This is what I observe. This is what I observe. That's the first thing that you observe, that this is equal to this. And it is given that T5 over T5 will be from the beginning, and 5th term from the end will be actually this. This ratio is given to be root 6 over 1. That ratio is given to be root 6 over 1, right? And on the basis of this, you are supposed to find n. N is a question mark. Now what is general term for this expansion? So let's write the general term as well. Here the general term TR plus 1 is NCR. This is N, NCR. In the binomial, the first term is 4th root of 2. Okay. So we'll also think of 4th root of 2 power n minus r. And this is 4th root of 3 in the denominator. So this is 1 over 4th root of 3 raised to power r. This is what you'll have. Is that okay? Yes. Since you have written the general term and you also have this expression, let's begin from here. Let's begin from here and substitute the general terms. So what you observe is, therefore, T5 over Tn minus 3 can be written as T4 plus 1. Tr plus 1 is what we are interested in. And this is Tn minus 4 plus 1, where r is equal to n minus 4. This ratio will be equal to what? This ratio will be equal to, let's take a look at, this is NC4 times 4th root of 2 power n minus 4. Can you observe that? This is n minus 4. And what is this? This is 4th root of 3 power minus r, which will become minus 4. Is that okay? Yes. And after writing this, the next thing that we'll write is the denominator. The denominator will be equal to NCn minus 4. Since r is replaced with n minus 4, so this will become NCn minus 4. 4th root of 2 power n minus 4. What will that be? Actually 4. And 4th root of 3 will be raised to power this n minus 4 with a minus, since it was in the denominator, right? Since it was in the denominator. Okay, once you have written this properly, what next? So let's see what all gets cancelled over here. I observe that NCn minus 4 and NC4 are exactly same. Yes, that's okay. What else? What will this simplify into? So this term will go, this is power n minus 4, this is power 4. We can combine them and this will become 4th root of 2 power n minus 8. Is that okay? Yes. And this is 4th root of 3. This is also 4th root of 3. The powers will come at the top, and what you'll get is 4th root of 3 This is minus 4. This will become n minus 4 minus 4, which will become n minus 8 over here. In the denominator, you will have a 1. Is that okay? Yes. Powers are same. Let's multiply them together. This is 4th root of 2 and 4th root of 3 will become 4th root of 6 power n minus 8 over 1. But what did we begin with? We begin with this. This is equal to this. It is already given to be root 6 upon 1. So this is equal to root 6 over 1, which is given. Okay. And this is 4th root of 6 power n minus 8. The denominator is 1, by the way. The denominator is not 8. The denominator is 1. Let's not make a mistake over there. So this is 6 power 1 by 2 and this is 6 power n minus 8 upon 4. Therefore, n minus 8 upon 4 is equal to 1 by 2. And this gives me the value of n as 10. The value of n that we get is 10. Is that okay? Yes. So, that's all. Yes. That's all. The value of n that we get is 10 and that was what was being asked. N minus 8 by 2, this becomes 2. 2 plus 8 is 10. And yes, that is my answer for this question. Simple? Yes, pretty simple. To solve this, once you have written this properly and simplified this expression, then it is very easy to find the answer. Yes, let's solve this question next. The question says expand using binomial theorem. Now, how do we expand this? Is this a binomial? No, this is a trinomial. There are 3 terms in there. But if you want to use binomial theorem, let's club 2 terms and try to expand. So what do we have? We have 1 plus x by 2 minus 2 by x. Let's club these 2 terms together and convert this into a binomial. So what we have is, this is the first term of binomial, this is the second term of binomial, and now let's expand this. What do we get over here? Is 4c0, the first term, 1 plus x by 2 raised to power 4. Minus 2 by x power 0, which is 1. The next term will be minus 2 by x power 1. There will be a minus. Let's bring that over here. 4c1, 1 plus x by 2 power 3 times 2 by x. Since minus has already been brought outside. Next is 4c2, 1 plus x by 2 power 2 times 2 by x power 2 is what I get. This is what I am getting. Next, minus 4c3, 1 plus x by 2 times 2 by x power 3 is what I'll get. And the next term will be 4c4. This binomial, this term raised to power 0 and this term raised to power 4 is what I get. 2 by x raised to power 4 is what I'm getting over here. What next? Next is simplification. Okay, simplification. But before that, we need to expand this one as well, right? Let's try to expand this one. This becomes 4c0, which is 1 times, this is power 4. So we'll have to use binomial again. Yes, we'll have to use binomial again over here. Let's do that. This will become 4c0, 1 power 4, which is okay, 1 only, plus 4c1, 1 power 3 times x by 2, plus 4c2, x by 2 whole square, plus 4c3, x by 2 power 3 plus 4c4 x by 2 power 4 is what I'll get over here. This is the first term expanded. This first term expanded into this. Then you have minus 4c1, which is 4 times 1 plus x by 2 power 3. What will happen to that? That can also be expanded. There's a 2 by x. Let's bring that 2 by x over here. And if you want, we can also multiply them together. This becomes 4 times 2. So what you'll get is 4 times 2x. Let's write 4 times 2 by x separately only. Okay. Since next term will have a 4c2, we'll have to write that separately. What about this bracket 1 plus x by 2 whole power 3? This will become, this is a plus b whole cube, which is very simple. A cube plus 3a square b plus 3ab square plus b cube. And this is directly from binomial theorem only. So let's apply that. This is a cube plus 3a square b. Now a is 1 only, right? So 1 square is 1 plus 3a, that is 1, times b square plus b cube, that is x by 2 whole power 3 is what I am getting over here. Is that okay? Yes. So that's this term with a minus. The third term has 1 plus x by 2 whole square. We'll have to expand that as well. So let's focus on the third term now. 4c2 is 6. This 2 by x whole square is actually 4 by x square. and 1 plus x by 2 whole square, that will be 1 plus 2 times 1 times x by 2, that is x, plus x square upon 4. This is x by 2 whole square, right? A square plus 2ab plus b square. Then you have 4c3, which is 4, and 2 by x whole cube, which is 8 over x power 3. And you have 1 plus x by 2 in the bracket, let it remain as it is. We'll multiply that, but let it remain as it is for a minute. 4c4 is okay. This is 1 times 2 power 4 is 16 over x power 4 is what I'm getting over here. For the next term, let's choose another color, and okay, now let's expand. And since we have already expanded enough, let's multiply them and see where do we get. Let's simplify these terms. 4c0 is 1 plus this is 4c1, which is 4 into x by 2 is 2x. Okay. 4c2 is 6, x square upon 4. 6 upon 4 will be 3 upon 2. So this becomes 3 upon 2 x square. 4c3 is 4. This is x cube upon 8. 4 upon 8 is 1 upon 2. So this becomes x cube upon 2. Plus you have x power 4 upon 16. Okay. These are the terms that you have. Then you have 8 by x over here, and we'll multiply them inside with a minus. This is 8 by x times 1, which is 8 by x with a minus. Then 8 by x into 3 by 2. 8 by 2, sorry, 8 by x, 8 into 3, 24 by 2 is 12. 12x upon x is 12. Minus 12 is what I'm getting. Next, you have x square upon 4. Okay. Here you have a x. So this term will have a x over here. And what will be the coefficient of this x? Let's take a look at this. This is 3 upon 4. This is 8. So this will become 8 times 3, 24 upon 4, which is 6. 6x. Okay, what about this term? This is x cube upon 8. This is 8 upon x. 8 will get cancelled. X cube upon x will be x square simply with a minus. Obviously with a minus. Let's not make a mistake in that. Your minus x power 2 is what I'll be getting. Next term after that. This is done. Next term will be this. 6, 4, 24 upon x square times 1 is 24 over x square only. What about the next one? Into x. 24 upon x square into x will be 24 upon x. When we multiply by x square upon 4, this is 4. 4 will get cancelled. X square will get cancelled. What you'll get is simply 6. What next? 8 times 4 is 32 upon x cube times 1 with a minus 32 upon x cube is what I'll be getting. And when you multiply with x by 2, you'll get 16 over x power 2. Then you have 16 over x power 4 over here. Yes. And one last step remains, that is to add like terms together. Let's add the like terms together starting from the highest power of x. What's the highest power of x that I observed? This is x power 0, x square, and then you have x power 4 as well. Yes, this seems to be the highest power. There's only one term of x power 4, one term of x cube, x square, x and constant. Constant is there, x is there, x square is there, constant is there. Okay, let's add the like terms. Let's begin with x power 4 upon 16. This is the single term, only term. Then you have x power 3. There's no other term of x power 3. This is the only term. This is x power 3 over 2. After that, you have x power 2. And yes, there are other terms. This is 3 by 2 x power 2. This is x square. So 3 by 2 minus 1 is 1 by 2 x square. Is there any other term over here? No, there's only term related to x square. So this is 3 by 2 minus 1, which is 1 by 2 x square. This is x square by 2. What next? For x, you have a 2x over there. You have a 2x over there. You have a 6x. 2x minus 6x is minus 4x. And you don't have anything else. This is minus 4x. Next, constant term. There's a 1 over there. And there's a minus 12 and plus 6. So 6 plus 1, 7 minus 12 is minus 5 over here. This is what I'll be getting. Right. What else? There's a minus 5. And when we talk about 1 upon x, coefficients of 1 upon x. So, this is 1 upon x. This is 8 upon x. This is 24 upon x. Minus 8 plus 24 upon x. Yeah, 24 minus 8 is 16 upon x. So, plus 16 over x. This is what I'll be having. Next, 1 upon x square. So, 1 upon x square starts this. This is 24 upon x square and this is minus 16 upon x square. 24 minus 16 is 8 over x square is what I'll get. Then 1 upon x power 3, there's no term over there. Okay, there's no term up till here. This is minus 32 upon x power 3. Then you have x power 4, 16 upon x power 4, there's no other term. This is 16 upon x power 4, and yes, that is my answer for this question over here. After complete simplification, this is the final answer, as you can see behind me. Is that all? Yes, that's all in this question. Let's discuss this question next. The question says, find the expansion of this using binomial theorem. So what are we supposed to do over here? We are supposed to expand. This does not look like a binomial. This looks like a multinomial. Okay, but we can use concepts of binomial if you apply it smartly. And let's apply some smartness over here. And what I see is, I see a 3x square minus 2ax. Okay, and then there's a 3a square over here. Let's club these two together. And this becomes one term. Take the bracket, and this is power 3. Okay. So now you want to apply binomial on this. Yes, I want to apply binomial on this. This is a plus b whole cube form. There's one term a, the other term is b, and we want to apply whole power 3. Okay. A plus b whole cube is pretty simple. This is a cube plus 3a square b plus 3ab square plus b cube, using binomial theorem once again. Let's see. A plus b whole power 3 is nothing but 3c0 a power 3 plus 3c1 a square b plus 3c2 a b square plus 3c3 b power 3, which simplifies to a cube plus 3c1 is 3 a square b plus 3 ab square plus b power 3. Why not use this directly? Obviously we'll use this directly, right? Since we know this, we'll use that directly. Now how do we go about doing that? This is a, this is b, and whole power 3. Let's apply this. This is a cube, 3x square minus 2ax cube plus 3 times a square times b, which is 3x square minus 2ax whole square times 3a square. Okay, plus 3 times the first term raised to power 1, 3x square minus 2ax, and the second term 3a square raised to power 2. The last term will be b cube, that is 3a square power 3. This is what you'll have. Okay. What next? There's a cube over there, there's a square over here. We'll have to expand these as well. Let's show it. This becomes a minus b whole cube, which is a cube minus 3a square b plus 3ab square minus b cube. So this is a cube, which is 3x square power 3 minus 3 times 3x square power 2 times 2ax plus 3 times 3x square times 2ax power 2. A cube minus 3a square b plus 3ab square minus b cube, which is 2ax power 3. Okay, that's the expansion of this. Yes, that's the expansion of this. Let's put it in a bracket. Okay, the next term is plus 3 times 3a square is what I already have, and then there's a huge term. What's that? 3x square minus 2ax whole square, which is a minus b whole square, that is a square minus 2 times a times b and plus b square, which is 2ax whole square. This is this term over here. What about these terms? These are pretty simple. Yes, these are pretty simple. Let's write them also down. This is 3 times 3a square whole square is 9 times a power 4. Okay, then you have 3x square minus 2x in the bracket. Let's write that also. Okay, and this is 3a square power 3, which is 3 power 3, 27, a power 6 is what I'll be getting. Yes? Okay. Now the only thing which remains is simplification and addition of like terms. Let's simplify each term first of all. What is this term simplified into? This is 3x square power 3, which is 3 power 3, 27, x power 6. This is 3 square is 9 and another 3 is 27, and there is a 2 as well. Okay, let's multiply that 2 as well. Why leave out that 2? Let's multiply that 2 as well. And what do we get? 9 and 3 and 2 will be 9 times 6, 54. X power 4, x power 5, a. This is what you get. 27 times x power 6 minus 54 x power 5 times a. What is this? This is 2 square, 4. 4 times 3 times 3. 4 times 9 is actually 36, right? 36 times, there's a x square, there's a x square, this becomes x power 4, then there's a a square. This is what you get, right? What next? This is a minus, 2 power 3 is 8, then there's a power 3 and x power 3. X power 3, a power 3 is what I'll get over here. Next, this term is 9a square, let's multiply with this. What is this term over here? This is 9x power 4, 9 times 9 is 81. 81, there is a x power 4, there is a square. Let it be. What next? Then you have a minus over here. This is 3 times 2 times 2. This is 3 times 4, 12. 12 times 9 is 108 with a minus. Okay, those are the coefficients. You have x square into x is x power 3a into a square will be x power 3 a power 3. Is what you'll get, right? What next? This is 4 a square x square. This is 9. This is 36 x square a square and a square will become a power 4. This is what you'll get. What next? This term. This is 9 times 3 is 27 times 3 is 81 and you have x square a power 4 is what you have. This is a minus. This is 27 times 2 is 54. Okay, and you have a power 4 a times x times a power 5. Then you have 27 times a power 6 is what you have at the end. And now let us merge the like terms. We have simplified each term. Now let's merge the like terms, add up the like terms. So begin with x power 6. What do we have? We have terms like x power 6. If there's x power 5, there's a11. If there's x power 4, there's a power 2. If there's x power 3, there's a power 3. X power 4, a square. X power 3, a power 3. Okay, there are similar terms. X square, a power 4. Okay, this comes over here for the first time. X square, a power 4 also comes over here. X, a power 5 and a power 6. So if you observe, the powers of x and a add up to 6 in each term. Okay, let's arrange as decreasing powers of x. Decreasing powers of x, yes. So what do we have? We have, this is x power 6. Is there any other term of x power 6? No, this is a power 6 which will come at the end. A power 5 will also go at the end. A power 5, a power 2, a power 3 and a power 5 will go at the end. Okay, sorry, this is x power 5. This will remain at the beginning. This is 27 times x power 6. Next is x power 5. There's a term of x power 5 over there, minus 54 x power 5 a. And is there any other term of x power 5? No, there's no other term. So let's write it minus 54 x power 5 a. Let's choose a term of x power 4 and we have 36 x power 4 a square, 81 x power 4 a square. Is there any other term of x power 4? No. 81 plus 36 is 117, right? 117 x power 4 a square is what I'll get over here. This is what I'll get. Next, x power 3 a power 3. This is one term of x power 3 a power 3. And if there is any other term, yes, this is another term. 108 and 8. Is there any other term? No. So minus 108 minus 8 will be minus 116. X power 3 a power 3. Next, we have dealt with this term. X power 4 is done, x power 3 is done. Let's focus on x squared next. These are two terms containing x square, 81 and 36. 81 and 36 added together will be 117. As you have just seen, this is plus 117 x square a power 4. Similar to that one. Next, what you have is x a power 5. And is this the only term? Yes, this is the only term of x a power 5. What is that? What next? 27 times a power 6 is what I get. And yes, that's all. This is the complete simplification of that expansion. Find the expansion of this using binomial theorem, and that is what we have done over here in this question. Is that all? Yes, that's all in this question. Let me get aside so that you can take a look at this complete solution. Okay, yes. With this, we come to the conclusion of this miscellaneous exercise from the chapter Binomial Theorem. There were some pretty interesting questions in this exercise especially. Some questions involved a lot of calculations. Actually, plenty of them involved a lot of calculations. But I hope you were able to go through those calculations, manage those calculations and practice those calculations, right? It is very important after you observe these video solutions, you should be able to practice these questions and solve such similar questions on your own. That is very, very important. So for that, what you can do is simply redo the questions that we have just solved. The same questions would actually be, once again, will increase your level, will improve your level, no doubt about that. And once you're done with that, you can practice new questions as well. Another thing which I said at the very beginning is solve the miscellaneous examples as well, right? Those are not something that we're discussing over here, but you should go through the miscellaneous examples. The examples just before the miscellaneous exercise are important and you should go through them as well. And with this, obviously, we come to the conclusion of this chapter, this exercise. We'll meet in the next session, but yes, don't forget to subscribe to the channel of Vyas Edification if you haven't done so. And also like and share this video if you have enjoyed watching the solutions with us. We are bringing this live to you and yes, we are enjoying it so much. So keep commenting, keep liking, sharing and subscribe to the channel of Vyas Edification. All the best.